Exercise 17c, differentiating x to the negative n. So when we've got a little minus sign in the power, that's just the same as a fraction. That's same as putting that to the denominator. So I almost like to think that if I zoom in here, this minus n, I often like to think that that minus n, or to the power of minus n, is the same as that little fraction there. So that's that's my memory of how it works. So when you're having to derive anything that has something in the denominator, it is highly recommended that you put it in the power of that negative there. Now, for the most part, for year 11, all of our derivatives that you would be expected to do would be something in the form of 1 over x squared or something along those lines, where you would write it as x to the negative 2. So therefore, the derivative of that would be just negative 2x to the negative 3. And exercise 17c is no different from that. The only issue is that there is a couple of other questions, a bit of a curly questions here you might have, where you need to do things by first principles. And the following example is one of them. So we have this hyperbola, 1 over x plus 2, which we need to do by first principles. So to find the derivative of first principles, of course, we need an x1 and a y1. So since we're wanting to find the derivative for this, for any value of x, it's just going to be x. x2 is just going to be x plus h. y1 will be substituting x back into here, which is 1 over x plus 2. And y2 will be 1 over x plus h plus 2. If you haven't already figured it out, why this is going to be revolting is we're going to get fractions on top of fractions. But let's start. If you have terrible handwriting, this is going to be really awful. I'd really recommend a large font when doing this. So we've got this fraction on top of another fraction, and they of course got different denominators, because why would it be easy? So we need to make sure they're the same denominator. The easiest way is just to multiply both sides by the other denominator. So now we have common denominators. The trap people fall into here is they'll only do minus x, but actually it should be minus x, minus h, and minus 2. So we've now done the subtraction of that fraction there. And so now we just got this minus h over this horrible brackets all over h, which we can simplify in a number of ways. You might remember your fraction simplification, or fraction division, I should say, where this is basically what this is. That is what I'm just rewritten the fraction as a division. That's what it's been expressed as. And we can also rewrite that to be as a multiplication, which means that can cancel out. 1, 1, assuming that h is not equal to 0. So then this now becomes negative 1 over x plus h plus 2, x plus 2. And so the limit as h approaches 0 is going to be negative 1 over x plus 2, x plus 2, which is negative 1 over x plus 2 squared, or negative x plus 2 to the negative 2. So once again, that question, so we had to find the derivative. So if we had f of x was equal to 1 over x plus 2, which you can write as x plus 2 to the negative 1, and therefore the derivative was equal to negative x plus 2 to the negative 2. Example 2, we're going to differentiate each of the following. So once again, we want to make sure everything is lovely and simplified and written in index notation rather than fractions. Don't get confused between your z's and your 2's, as I often do. So we're going to differentiate. So all I've done is I've just rewritten to get rid of that fraction. So the derivative is equal to negative 2 times 3, x to the negative 2 minus 1, plus 2 times 5, x to the 2 take away 1, which is negative 6, x to the negative 3, plus 10x. And on this side, we want d dz this time is equal to negative 3 times 3z to the negative 3 minus 1 plus negative 2 times z. Negative 2 take away 1, which is negative 9z, negative 4 minus 2z to the negative 3. You don't need to simplify that any further. It wouldn't help at all. You could just leave your answers as such. Example 3, show that the derivative for the function f is all values with except 0. F of x is 2 over x is always negative, so that's a hyperbola. So what it's saying is that you need to show me that if I was to draw this graph of y equals 2x, this hyperbola, the derivative is always negative. Well, you can tell by just how it slopes. It always slopes down. But we need to do probably some little bit more magic with mathematics to do that. So let's just find the derivative. So the derivative for this is going to be negative 2x to the negative 2. How did I do that? So that was f of x is the same as saying 2x to the negative 1. I just took the negative 1 down and minus 1 there. So it's a negative. It's actually become a truncus. And what I can do is I can actually sketch the derivative graph. And so, in fact, I might label that as f apostrophe x, and this is x. It's a negative or upside down truncus, so it's going to look something like this. So I've put my asymptotes in, and no matter how further we go in the negatives or in the positives, x will approach 0, but it will never get to 0 or above. So for all of x, the derivative will always be less than 0, therefore always negative.